Now that you've learned a little bit about ionic compounds, learn about how to write the formulas for them. So the formula unit is the lowest whole number ratio of ions in an ionic compound. Ions will combine and balance to form a neutral compound. So the net overall charge has to be 0 in these ones. So for this sake, if you look at this picture, calcium is a +2 charge, it's in group 2. Fluorine is a -1 charge, it's in group 7A. What happens is your group 2 elements are always going to form a +2 charge. Your group 7A elements or group 17 halogens will always want to form a -1 charge. So you would need 2 fluorines to get a total charge of -2 to balance out your +2 charge on your other side. So that my overall charge +2 -2 has to equal out to 0 for my overall net charge. And then my formula then would be I have 1 calcium and 2 fluorines. So my subscript there tells me how many of each thing I have. You don't need to write a 1 for 1 calcium, but you do need to write a 2 for having 2 fluorines. The general rule is the cation will be written first in the formula, and the anion is second in the formula. Your cation is usually your metal, and it will be your positively charged one, and your fluorine or your anion is your negatively charged ion, which in this case is fluorine. Your subscripts are written after the symbol to indicate the number of each ion. So I have calcium, I just have 1, so I don't need to write 1 because it's understood. And then I have 2 fluorines, so I have a subscript of 2, CaF2. It's written right behind the fluorine because that means I have 2 fluorines in my compound here. Subscripts also must be written in the lowest whole number ratio. So really I could have another calcium and 2 more fluorines and have Ca2F4, but I could reduce that. So if you ever accidentally get them too high, or in this case Pb2O4, I can reduce that down to PbO2, the lowest whole number ratio. No charges are written in your formula. Notice I didn't put calcium as a +2 or that fluorine was a -1 in the formula. That is left out there. So here are just a couple example ones for you to add to your notes somewhere to help you remember and refresh how to write these formulas. So if I had the name silver chloride, I would look up the symbol silver, which is Ag. And then silver, even though it's a transition metal, it's one that always has a +1 charge. So in silver's box, you could write that it has a +1 charge because you can remember that. And then chloride just means I have a chlorine, and a chlorine's in that group 17 or 7A, so it has a -1 charge. My charges would already balance out. I just need one of each, so I can put them together and make a formula AgCl. Remember, you don't have to write the subscript if it's only one of that element. Then I have lead for sulfide. This Roman numeral of 4 means that I have a +4 charge on lead. So since I don't know lead's charge by looking at my periodic table, the name should tell me a Roman numeral to tell me what the charge of that element is. So in this case, lead 4 means that lead has a +4 charge. That's what the 4 here means. If you ever don't know what those Roman numerals mean, on the back of your periodic table, there is a list in a table with the Roman numerals for you to reference what each of them are. So if I have lead or Pb +4, and then sulfide just means I have a sulfur. Sulfur is in group 16, so it has a -2 charge. So I combine those. I need to have 2 sulfurs to combine my +4 here. So I need 2 -2s to get an overall -4 charge to balance out my +4 charge here. So I have PbS2. I have 1 lead for a +4 and 2 sulfurs. And so I need 2 sulfurs for an overall of a -4. If I had zinc phosphide, zinc is another one in your transition metals. These are the only 2, silver and zinc, that they always have the same charge. So zinc is a +2, so you're welcome to write in zinc's box +2 to remember that zinc is always a +2 charge as well. And then phosphide is in my group 15 or my 5A, so it has a -3 charge. So this is where you get a little more tricky. I'm going to have to find my least common multiple between 2 and 3. So I know how many of each one I have to get. Otherwise, you can draw them, and sometimes some of you guys might figure it out pretty much on your own. So I have zinc +2, phosphide -3. To get them to balance out, I'm going to have 3 of these and 2 of these for an overall charge of +6 and -6. So if I have 3 zincs +2, I have zinc +2, zinc +2, zinc +2. That's an overall charge of +6. So I have Zn3, and then I have P -3, P -3. I have 2 phosphides. That's an overall charge of -6. So my overall charges when added together, have a net charge of 0. So I can have Zn3p2. Another one, now we're going to talk a little bit about polyatomic ions, which we'll get into in a second. But sulfate is a polyatomic ion. If you see something that ends in ate or ite, that's a clue that it's a polyatomic ion, and you want to look at your polyatomic ions table to figure out which one they are. So I look up sulfate, it's SO4, and it has a -2 charge. Magnesium is in my group 2, so it has a +2 charge. In this case, my -2 and +2 already cancel each other out, so I just have MgSO4. I don't have to do anything. Notice I left my subscript from my polyatomic ion. It has to stay together as SO4. I can't just put SO or SO2. SO4 is sulfate, so I leave that as SO4. So I have MgSO4. Another one here, I have copper 2 nitrate. This Roman numeral again means that's the charge of the element that it came after. So copper's charge is a +2, copper 2, Cu +2. And nitrate again ends in ite or ate, so I know it's one of my polyatomic ions for my polyatomic ion chart. When you look it up, you see nitrate is NO3 with a -1 charge. If I have a +2 on my copper and a -1 on my nitrate, I'm going to need 2 of these nitrates to cancel out my 1 copper. So I have NO3 -1, NO3 -1. That makes an overall charge of -2 to cancel out my overall charge of a +2. So I need 2 nitrates. One thing you have to do with polyatomic ions is remember you have to leave them as NO3. NO3 here. I can't put NO2 because I need 2 of those nitrates. That would change what the polyatomic ion is. So I have to leave it as NO3. I'll put it in parentheses so I know that NO3 is one thing together. It's a polyatomic ion. And I have 2 of that polyatomic ion. So when I have copper, NO3, 2. A trick for when you're writing formula units, write both ions with their charges as superscripts. So Cu is a +3 and O is a -2 in this example. And then what you can do is you can crisscross the charges down, and that's a faster way to figure out what your subscripts are. But you have to take off the plus and minus in the formula. So in this case, I have Cu +3 and O -2. I would cross those charges down and across, and now I can see I need 2 coppers, which would give me an overall charge of +6, because I have 2 +3s. And now I have 3 oxygens for an overall charge of -6, so I have a net charge of 0. So if you cross your charges down and across to the opposite elements, it tells you what the subscript will be, and it's a faster way to do it if you don't want to do the calculations in your head. Some common mistakes to avoid. Your Roman numerals are not written in the formula. People tend to try to write, if it was copper +2 or copper 2 with the Roman numeral, I don't put that in my formula. That has nothing to do with my formula. It's just telling me my charge so I can figure out my formula. Another thing, your charges are not written in the formula as well. It's helpful to write them up there, but then when you're done, either erase them or rewrite your formula as the correct way. So up here, this is incorrect. My correct way of writing that would be CuO. This one's incorrect. I would be correctly writing it KBr. Another thing, don't drop your polyatomic subscripts. This is a common thing people like to do. When they know they need to have 2 nitrates, NO3, they need to have 2 of those, they just switch the subscript to NO2 and then call it good. Another thing they often do is maybe try to do 2 times 3 and say that it's NO6, or maybe they add them and it's NO5. That is not right. If you have more than one of your polyatomic ions, you have to leave them in parentheses and put your subscript on the outside. So in this case, this is not correct. I'm having trouble with those clicking. And down here, hydroxide or any of your polyatomic ions really need to have parentheses when you have multiples. A lot of times people forget the parentheses on hydroxides because they forget that there's no subscript in the polyatomic ion's name. So if you have multiple of a polyatomic ion, you have to put it in parentheses, or else you won't be able to tell how many of each one you have, and you have an incorrect formula.